Hey folks, this is your first video for your notes on tools. We use different scientific tools throughout the year, and so this is helping you learn their names and what they're used for. We're just going to go over the ones that are most commonly used in science, in 7th grade science. So you will write what I write, and if I write it, you should write it. Even if there's not a line for you to put it on, if I'm adding notes to it, then you should add notes to your page as well. Alright, so your first term is going to be thermometer. And most of you are familiar with thermometers that you use when you take a temperature for, like, if you're sick. But the ones we use at school look a little bit different. Looks like this picture on the right. But thermometers are used to measure temperature in degrees Celsius in science class. This is the symbol for degrees Celsius, the little circle and a C means degrees Celsius. In science, we use the metric system. So we use meters, we use Celsius, we use grams, we use mass, because we use the metric system in science so that scientists around the world can collaborate together and all be on the same page. That little red arrow is pointing to a little red cap on thermometers. Thermometers are round, so if it didn't have a flat surface on it, it could roll off and break. They are fragile. So that little red part is basically like a piece of plastic that is like a triangle, and it keeps the thermometer from rolling. This end down here is the part that gets submerged in the liquid, and that is what allows the temperature to rise if it is heated up or drop if it's cooled. When you're using a thermometer, you should remember that they're glass, and you don't drop them because they're fragile. We don't stir with them because they're glass and they'll break easily. And when we're using them in lab, we use them a lot of times with a hot plate. And so when we're boiling water and you put the thermometer in the beaker, don't sit it on the bottom, because the bottom of the beaker will get very hot because of the way it's sitting on the hot plate, and that could cause the glass to break. So while you're taking the temperatures in water, you should just hold it submerged in there, but not touching the bottom or the sides, again, because it's fragile. Okay, next we have a triple beam balance. And triple beam balances measure mass in grams. The symbol for that is just a lowercase g. And mass, if you don't remember from your previous science classes, is just the amount of matter in an object. Oops. So this is an example of a triple beam balance because it has 3 beams. The thing I want you to notice on this is the part that I circled, the part above it right here is like a blown up picture of that, and there's a white line on the bar, and you want that white line to be level with the 0 to be balanced. If it's below or above it, then it's either too much weight or too little weight, and you adjust it. When you're reading that, you should be eye level. Okay, next we have a graduated cylinder. Graduated cylinders measure volume in milliliters, and we use it for liquids, and the abbreviation is lowercase m, capital L. There are 3 things to do when you're measuring volume with a liquid, with a graduated cylinder. You're going to to read the water level eye level, so squat down and get your eye level with the height of the water. You're going to read it at its meniscus. Most, because of water tension, water will bead up on the side of a graduated cylinder, and so it's higher on the sides than it is in the center, and the center is the most accurate spot. And you want to have it on a flat level surface. So over here, where you see this blue added in part, is the meniscus. Let me do it in red and show you this part right here. So it looks like a half moon or something is what a meniscus looks like. You can see it better in this picture here where the arrow is pointing. Each graduated cylinder is measured differently in increments, so you have to look to see what it's going up by. This one shows 20, and then the next number above it is 25, so that means each one of the little lines counts as 1. So if you were looking at this graduated cylinder, this would actually be 20 and a half, because this next line right here is 1. So its amount of the volume in this graduated cylinder is 20.5. Okay, next we're going to talk about a hand lens. Hand lenses allow you to enlarge whatever object you're looking at. These are things that you can already see. You're looking at small print in the newspaper, and so you get a hand lens that makes it larger. You're looking at a design, you get a hand lens that makes it larger. So it just makes it bigger. Hand lenses are also known as magnifying glasses, and there's a picture of one right there. Next we have a beaker. Beakers hold liquid and solids. You should have S's on them. Liquids and solids, depending on what they are. It is not an accurate tool for measurement. Make sure you add the word tool in there. I think I left it off on your papers as well. As you can see in the picture, the increments are going up by 50s. So how would you ever know if it was between 200 and 250? What number is that? Is it at 210? Is it at 220? You wouldn't know because the increments are too far apart. That's why it's not an accurate measuring tool. Also, we'll show you, or we'll see test tubes from time to time. We use those in experiments. They are also glass. They are also fragile. They're also cylinder types, so they would roll if you didn't put them in something to stand them up correctly. Alright, next we have a meter stick. Meter sticks measures length, width, and height, or distance in centimeters. We use centimeters mostly in our class because we're measuring small increments. You can see, well, before I get to that, if you're measuring a far distance, you're going to use kilometers. Kilometers would be what you would use to measure from here to like Knoxville. To measure the width of your phone, you would use centimeters. And you can see on this picture here, like 6 to 7, that's 6, like it's showing you 1 centimeter between the 6 and the 7. And 1 millimeter is each one of those little dash lines in between the 6 and the 7. So those little dashes are millimeters, and then the numbers are showing you centimeters. And then one whole meter stick is a meter, and that's 100 centimeters. Alright, next we have a microscope. Allows you to see microscopic objects, things that you cannot see with your naked eye, which means you can't see them without assistance. Like, it's so small, you wouldn't be able to see it without the aid of the microscope. When you're carrying microscopes, you want to carry them with 2 hands, 1 hand on the arm, and 1 on the base. Also, another important thing about using the microscope is that when you are turning, these things right here are called the objective lenses, and those are what help enlarge the object. And so if you're going to turn them to get a better magnifying amount, a larger magnifying amount, then you need to always lower the stage when you turn those, because otherwise, if you leave the stage where it is, let me erase this. This part right here is the stage, and if you leave it as high as it was when you're on a smaller magnification and then turn to a larger one, that's probably going to be long enough that it could hit the stage and crack the lens. So you always want to lower these knobs here, put the stage up and down. So you always want to lower them down, and then you want to turn the objective lens. Alright, and then finally, our last couple here are going to be, excuse me, spring scale measures force in newtons. The abbreviation for that is just the capital letter N. These are 2 different spring scales. This one here is just a flat version. I've had students tell me before it looks like what you take the mass of to see how large a fish is if you're fishing. On this, and the kind that we have here, on one side it's got N for newtons, and one side it does have grams for mass, so you could use it for that. But the thing about using it is it doesn't measure large amounts of mass, so it would have to be something that's light. And then the yellow one is another example, and those ones that we have here only measure force and show the newtons. So force is the push or pull on an object. It's just how hard something's being pushed or pulled. Alright, and then finally density. Density is the amount of mass in a given space or object. So like if we wanted to know the density of this rock right here, we would have to find its mass, and you would do that by using a triple beam balance, and then you'd have to find its volume. Well, because it's not like a cube or something that's like flat and perfect shaped, you can't use a ruler to find its volume. You would have to do water displacement. So in order to do that, you fill the graduated cylinder up to a certain amount, put the object in, see how much it rises, subtract the difference. That's going to be, or subtract them, and the difference is going to be the volume of that object. So if you're finding the volume of a solid, like a cube, you would use the units grams per centimeters cubed, because you would take length times width times height to get the volume, right? That's how you find volume if it's a regular shaped object. If it's an irregular shaped object, or we're finding the volume of a liquid and we want to know the density of a certain liquid or this irregular shaped object, you're going to use liquid to find the displacement. The units you would use would be grams per milliliters, because you're using liquid to find volume. So it's going to be, I wrote over that spot. Hold on. So it's going to be density equals mass divided by volume. And the way I like to remember it is density equals a heart. And when you divide the heart, because you're doing math and you're using division, you get mass divided by volume. We will do examples of that in lab, so you will get to put that into practice. The next part on your paper is just a spot for you to write what is science. And just write this definition down. Science is knowledge that it's obtained through studying and observing the physical world, so everything around you, and that can be tested with a scientific method. I'm sure you've talked about the scientific method before. It's just the step or process you go through to solve a problem in science. The next part of the video is going to be you drawing examples. So you're going to draw pictures of each instrument we've discussed, and you're going to identify it by the name, what it's used for, and then also label its units. Remember, not all of these have units, but if it did have units, I told you what they were, so make sure you label them. If you have any questions, let us know.